And we're live. Welcome to the Terramate office hours, our bi-weekly developer office hours where we showcase you the different use cases of Terramate, what we've been working on. Um, and also we're here to basically answer all your questions. So, as always, we're live on LinkedIn and YouTube at this time. So feel free to ask questions in the comments, and then I'll address them each by their own, most likely closer toward the end of the session. Um, Also today I'm on my own, so usually my colleague Selena is here with me. She's on vacation today, well deserved. So it's just gonna be me. And yeah, thanks for writing in. Thanks for joining. Great to have all of you here. We've been working on a bunch of interesting things. Um, I think Terramate 0.8.4 has been released just a week or two back, and now we're working on the .9 release. There's a bunch of things coming now. Full support for workspaces in Terramate Cloud is underway. We shipped a simplified way of generating ad hoc HCL code in stacks, which is great. So that's an experiment. And we're also relaunching our docs. So fundamentally overworking our docs. I think this will launch latest tomorrow. So we're in the final steps of reviewing this. What are we going to discuss today? Um, so I think in the past, over the past few months, a lot of people came to us, whether it's in our Discord community. By the way, if you are not in Discord yet, feel free to join at terramate.io/Discord. Again, that's terramate.io/Discord. So our team is in there, and we're more than happy to address your use case, answer your questions. It's a pretty vibrant community. Today, though, we'll focus on stacks and on the graph-based orchestration in Terramate. So for the ones of you that already know Terramate, this will be more of an deep dive session to basically understand how the ordering of stacks when executing commands or workflows work, and also how this differentiate to other workflows and other tooling in the market. Because I think with Terramate, we're following quite a unique approach here. Awesome. Let's dive right in. I'm just gonna quickly change my screen here. All right. Let's move Zoom out of the window. All right. So what we'll be using here today is this repository Terramate Quickstart AWS that's available in our open source organization on GitHub. So this is an opinionated way that showcases the different capabilities of Terramate. So we basically use all the capabilities in here, whether that's orchestration, stacks, CI/CD integration, workflows, even the Terramate Cloud integration is built in here. To basically give you a starting point. So whenever you want to get started with Terramate, you don't have to engineer and put all of this together, but you can just start with a template. And I've basically cloned this to a private repository for the purpose of this demo, which we have here somewhere. And I did that so I don't pollute the public repository, but it's basically one-to-one representation, one-to-one copy. Awesome. And also I have opened this here locally in my IDE. All right, let's dive right in. So first thing I want to do is, so what you can, I want to explain this repository a little bit for you. So what you can see here is with some GitHub Actions workflows in here. So Terramate is not a CI/CD platform. Instead, we're integrating with any CI/CD platform out there. Right now, I think mostly used are GitHub Actions, GitLab, and Bitbucket pipelines, and we do this by bringing orchestration capabilities, observability capabilities, etc., to those to those platforms. They're great purpose-built CI/CD platforms in the market, and I think all of them are great products. But our way of thinking here is basically saying that you most likely already have in CI/CD, and you already pay for compute, so why not reuse this, right? And that allows you to basically leverage whatever you have already, so you don't need to buy yet another CI/CD platform. So what you can see is we have workflows for deploy, previews, and drift detection, and the documentation that we're now relaunching. We basically have a new section also where we explain the different concepts. So the approach that we follow here in Terramate is GitOps, and pull request based workflows, meaning that whenever you introduce a change to your infrastructure, whether it's provisioning or decommissioning infrastructure, managing the lifecycle around it, this is done through a pull request, right? And based on stacks. And stacks basically are a combination. So stacks are here in this stacks directory, and as of now, they're empty. So there's no stacks in this repository, but we'll create a few in a minute. And stacks, in a very easy sense, are basically a combination of infrastructure code, state that is most likely managed in a remote environment. So Terramate does not host any state backend for you. Instead, we assume that actually this is not what you want. You don't want us to have access to your state. You want to host it yourself. So there are plenty of options out there like S3, Google Cloud Storage, or even Terraform Cloud, and others, right? So we don't take care of that. We assume that you bring your own state backend, which also means that we will never access it or require any access to it. All right, so let's look a little bit at the concept of stacks here. Let me clear my screen. All good. With Terramate Create, I can basically create a new stack. We've talked about this multiple times in the past, and I think what I would like to showcase here today is that what's a typical use case for stacks. So with stacks, you can manage perfectly well entire environments or end-to-end services, right? And the way that this can be done is by either putting all required resources into a single stack, or by nesting stacks into parent and nested stacks. And we'll look into this in a second. So for now, let's basically just create a new stack that we call stacks, and then maybe we just call this dev. So in here, I basically created a stack, and what you can see already is that this stack here comes with a backend.tf, a terraform.tf, and a stack.tm.htcl, right? And so if we look at the stack.tm.htcl, this is a way of configuring a stack in Terramate. So what Terramate actually is doing here is that compared to many other tools in the market, we say that you already use HCL, HashiCorp Configuration Language, right? Which is the language that you use to script Terraform and OpenTofu and whatnot. And it's unnecessary for you to use YAML in this case, or JSON. Instead, we assume that HCL is actually the more suitable configuration language because A, you already know it, and B, we can use advanced capabilities in here, such as functions, for example, Terraform functions. They're all available in here. So what Terramate actually does is Terramate takes HCL as a language and extends the language with language constructs, right? For example, it's this stack block here that you can, let me see, this stack block here that you can see in my IDE is basically a configuration block that tells Terramate how to configure three things. A, the metadata of a stack. So metadata we can see in here. It's a name and description of a stack. So we could say this is the dev environment. This stack contains all resources to deploy a dev environment. Okay. So now what we have here is basically saying that in this specific example, this stack is a mono stack, and we would put all the resources inside, and it represents a specific environment, right? And then you can see with an ID here. And the ID is a unique ID, which basically gets created and is unique for every single stack in our Terramate project. So Terramate takes care of that for us. So now if you look at the other and remaining files in here, that's interesting is that you can see we automatically created this backend.tf and this terraform.tf, which is sort of boilerplate code in Terraform. So this is required to configure Terraform, to configure the Terraform version, the providers used, the state backend used. And then if you look at this backend here, so let's open this up, you can see, oh, this file actually contains a header, Terramate generated automatically, do not edit. So this indicates that the file was generated using the Terramate code generation. And we use an S3 state bucket here. And what you can see is that the key that this specific stack is using is magically referencing the unique ID that is configured in the stack's metadata. And we will look into this in a second, how this actually works. Also, too, you can see that in here, there's another generated file. So this is the terraform.tf, which basically configures the required Terraform version, and also the AWS provider that we need here, the region and whatnot, right? So now where is this coming from? Terramate has this construct of code generation, so we can basically use Terramate to generate all sorts of code in stacks. For example, we could say, hey, we want to generate a bunch of Terraform files, OpenTofu files, or JSON files, or YAML files, right? So let's look into this. In imports backend.tm, .hta, you can see that I have another Terramate configuration block here. And this configuration block basically says, hey, generate an HCL file called backend.tf in every stack that does not contain a tag, no backend. Okay. And then basically fill it with this content, whereas here we define the Terraform block. And for example, if I introduce a typo here, you can see that the IDE gives me feedback, right? And that's because Terramate has a language server running in the background, which basically passes the Terramate language constructs and gives me feedback right away. So we can actually validate whatever we do here. Awesome. So now if you look at this, we can see, so in theory, if I add a tag no backend to my newly created dev stack, this should not create any files, or at least not the backend.tf. So let's do this. And then we basically just add this tag here. So tags is basically just a list of tags. We have a formatting command in Terramate 2, which can be used to auto-format code. So let's do this. I just triggered it. Now you can see it automatically detects malformatted stacks, and it formats the Terramate configuration for us. Awesome. So now what? I added this tag, and I can run the code generation by running Terramate generate. So what Terramate generate will do here is it will basically look at my code generation configuration and understand whether or not code needs to be regenerated, removed, added based on the conditionals that I have here. So if I run this, you can see that Terramate says, oh, basically, we added this no backend tag to the stack. That's why the backend disappears here, right? If I was to remove this and I run the generate command again, you can see the backend is back in there. So now this is a single stack, meaning that I could now just add my main.tf here and then just start adding a bunch of Terraform resources. So I can, for example, say, please provide me with the Terraform code to provide to configure 3 Terraform null resources. Let's see what Copilot is giving us here. Awesome. So now what I have here is basically a stack that has its own state managed in an S3 backend. It also has its own Terraform configuration in here. And we basically just added the main.tf, so native Terraform code that declares 3 null resources. Okay, so what's next? With the Terramate list command, I can understand what sort of stacks I manage in the project. And the Terramate project basically represents a repository. So if I execute this, Terramate will basically scan my entire repository and provide me with a representation of all stacks, with a list of all stacks managed here. And the interesting thing here is if I, for example, create a new branch, I call this demo branch, get status, and now I add this directory stacks dev to my branch. Just check this in by writing a commit, add a almost empty stack. If I now run Terramate list, changed, typo in list, changed, this would basically look at my current branch compared to the main branch or any other commit, so it's configurable, and provide me with a representation of all stacks here. So what does that mean? If I now, for example, run Terramate run changed Terraform init, this would only select this dev stack here for execution because it's the only stack that we touched. And the idea here is that what Terramate orchestration actually does is it creates a graph, a DAG, of all your Terramate stacks, so that so in directed acyclic a graph of your Terramate stacks and it understands dependencies. So you can navigate this graph and filter this graph and invoke commands such as Terraform plan and Terraform apply. So let's look at this in practice. So what I'm going to do here is I am actually removing all of this, and we'll look at into an example with a little bit more of a nested kind of structure. So let's assume I want to create a new environment, and this environment should manage VPC, a database, and the Kubernetes cluster. So what I would do here is I would basically not create a stack, but basically create a directory, stack dev. So this is an empty directory. And inside of this directory, I can create the stacks used to manage the different resources. So I'm gonna go ahead here and create a stack dev VPC. And I call this stack dev Kubernetes and database. So what you can see here is that now we have a directory, and this directory basically contains 3 stacks, right? So this is a directory where we have 3 stacks that are managed as parent stacks. Those stacks aren't nested. What does it mean? If I run Terramate list, you can see that what would happen here is that basically it gives me the list of my newly created stacks, right? If I was to look at the graph of this, I can use Terramate experimental. I think it's an experimental namespace, run graph, right? So now this gives me a representation of my graph of stacks ready to be executed. Awesome. So let's do the following. In a more close real-world scenario, the database and the Kubernetes cluster would have a dependency to the network, right? And that's because usually you deploy those resources inside of a network. So the network needs to be there and exists before you can actually deploy those resources, right? So what we can do here with Terramate is we can basically just move the database and the Kubernetes stack, so this K8S stack, into the VPC stack. Let me do that. So basically just using the file tree here, the directory tree. And now what we end up having is we have a single stack, a parent stack VPC, and two child stacks that are nested on the same level called database and K8S. And now what you can see is if we print the graph again, what the graph's basically saying, so first, VPC is the first element inside of our graph. Database is then the second one, and Kubernetes is then the third one. And the reason for that is that Terramate will detect that those are nested stacks that depend on each other, right? Stacks that depend on each other will always result in a tree hierarchy of dependencies, whereas the nested stacks inside of VPC are next to each other and independent to each other, means they can execute in parallel, right? So if we look here at the run order, Terramate list run order, you can see that, hey, this deploys the VPC first, then it would consider VPC database and then VPC K8S. If we move this out here back to the same level, so database back to the dev directory, and we invoke this, you can see that, oh, now database and VPC on the same level can be executed in parallel. And only Kubernetes, the K8S stack, is nested and hence results in a dependency in this graph, right? So let's actually move the database back in here. So now what? If I want to run a command in here, we can use the orchestration to navigate this graph. So with Terramate run, we can basically execute any command inside of stacks. So in theory, what should happen here is this is sequential execution. So in theory, this should first execute hello world in the FTB. Actually, let me show the run order again because we didn't show the updated run order. So this should first execute, of course, in VPC, then VPCDB, and VPC K8S. So let's try this. Echo hello world. And this repository is untracked files. Okay, that's in safeguard that I always forget. So what this does is basically, Terramate comes with built-in safeguards. We can look into this here. And actually quite good. So safeguards prevent you to run commands inside of stacks if you have untracked files or outdated code generation or so. Just in case if you run Terraform apply or Tofu apply locally to prevent you from overwriting changes that have not been reviewed or checked into the remote repository, right? We can disable all of those by passing X or by basically disabling them in the Terramate configuration. Awesome. So now in our specific case, we'll just disable them for this specific run. And now what you can see is the expected behavior happens, right? So the orchestration here will navigate this graph, right? And will sequentially execute in VPC. You can see this here. Then in VPCDB, we can see this here. And then in VPC K8S, we can see this here. So that's sequential execution. If we want to use parallelism, right, to speed things up, such as like running a bunch of stacks in parallel, we can do this. We can basically say, hey, now run this in parallel using 5 threads. So what this will do is instead of navigating this tree here, let's actually look at the run graph, run experimental run graph again. So instead of navigating this graph here sequentially, what parallelism will allow us to do is parallel, see, this is parallel 5. This will execute the graph in parallel using 5 threads. And now, because we have this hierarchy of dependencies, whereas DB and KLS stacks depend on VPC, it will still preserve the order of execution in the sense of it will first sequentially execute the VPC stack, and then in parallel, the both child stacks that are independent to each other. So if we do this, you can see the VPC stack gets executed sequentially. And after that, it just starts parallel execution of the VPC and, of the Kubernetes and the DB stack, right? So how would this look like more in a kind of revert scenario? Let's add a bunch of files here. Add 3 Terraform null resources. Let's just ask Copilot to do this for us. I'm too lazy to write the code myself. Awesome. So we have 3 null resources in the VPC stack. And now I basically just want to do the same in the DB stack. Let's just add 1 null resources in each. So we have some resources in here. And then inside the Kubernetes stack. Now, of course, in a more real-world kind of scenario, we would actually add the Terraform resources here, manage to deploy the individual cloud resources, cloud services, but that will probably take us a little longer than the remaining 50 minutes that we have. Okay, so now again, the workflow here for us to run this in automation would be to create a new branch, another demo branch. And now if you look at the Git tree here, we can see I check this in, Git status. You can see all the stacks. And I commit this. Add 3 demo stacks. Awesome. And now what I want to do is I actually want to create a GitHub pull request. So now, basically, instead of running the orchestration locally, Terramate integrates with all the CI/CD platforms, right? So you can you can install the CLI and GitHub Actions and GitLab and Bitbucket Pipeline and bring those orchestration capabilities to those platforms. So if you compare this with, for example, Atlantis. Atlantis is a great tool, but the orchestration requires you to configure it, so it's available at runtime, right? Whereas Terramate creates a graph in the backend, and you can still configure this graph, right? You can configure the orchestration behavior, force execution, configure before and after statements and those kind of things to basically say, hey, I want to override the default graph. You can also use change detection, which we already showed here, to filter the graph for stacks that contain changes only. But what this is doing now is, so basically it runs all of this in automation, right? And it shows me an overview of my change stacks here. Also a link to Terramate Cloud. And it says like, oh, so this stack, staff, VPC, here's the plan. Stack, staff, VPC, DB, here's the plan. Stack, staff, VPC, KLS, here's the different plan. And it does this in parallel. And it does this in parallel, but it still preserves the order of the outputs. So let's look at this inside of Terramate Cloud. And I'm gonna open my demo organization here. So, and here you can see a new pull request is available in Terramate Cloud. And this pull request basically gives us a representation of all stacks affected inside of a PR, right? The plans as well as the log lines here. And those log lines come from GitHub Actions. So what Terramate actually does is it looks at the plans, it looks at the logs, and it synchronizes those to Terramate Cloud. The big difference here is that Terramate will actually not send any secrets or so. So it will look at the plans. You can see this in the open source Terramate CLI. So it's all pretty well shown in there. Stripe and mask all the sensitive values, and then sends those mask values basically without any credentials, etc., to the cloud, right? And then in here, instead of having a file browser, we have a stack browser. So now, if I was to look again at my local repository here at my IDE, basically what I did is I provide a list of all stacks that contain changes. And then I'm saying, so now Terramate run on all change stacks in parallel using 5 threads, run Terraform plan, right? So now what this will do, if you look here at the graph, so this will traverse the graph, right? And run Terraform plan inside of my individual stacks. So the mental model here is that if you look at the way that Terraform is managed in a more conservative kind of environment, like you would find maybe 3 root modules, 3 stacks, that each of them represents an environment, dev, staging, production, right? And then all the resources are basically managed inside of those relatively big state files. The Terramate model here is that, hey, you can just you can just use the directory tree and map your cloud architecture onto the directory tree using different state files. And then Terramate, so it allows you to basically split up your state into smaller isolated units that can all execute in parallel. Terramate allows to detect changes in whatever stacks actually have changed, so everything else may not be considered or may. You can configure this and it detects the dependencies. This allows you to enable parallelism on a decent level, right? And it also allows you, and which is more important, to have seamless collaboration in large monorepositories. So we can work on this with like dozens of developers all working on different stacks without ever causing any conflicts, right? And then also too, because we use stacks to split up state, all those CI/CD runtimes are relatively short, right? So it means less costs. Awesome. So now let's assume I'm gonna add another stack here. What I can do is I can basically just clone this, saying so I can basically just clone whatever I have here, saying Terramate experimental clone stacks def to stacks prod. Let's do that. And now what you can see, Terramate replicates all of our stacks. And it basically updates those IDs here for us. It regenerates the code, etc. So this is one way of managing environments in Terramate. You can use a directory-based layout, but you can also use workspaces, for example, right? Because Terramate doesn't wrap Terraform in any sense. You can basically run whatever command. So now if we look at Git, let's add this here, and we say, hey, commit feed add prod, and we push this to another demo branch. Going back to GitHub here. And we're slightly running out of time. Then we can see what's happening. What happens is that basically the automation will run again. It will basically wipe the comment. So this is a comment that gets added by by GitHub integration here, by the Terramate GitHub bot, and it's fresh. And update this comment is in progress again. So we'll run a new plan. Let's wait for this. In the meantime, this also updates here in the cloud. Takes some time. So I can see all those plans are running. And then of course, because those are different environments, Terramate will download providers, etc., for all of those stacks, right? You can use caching to basically cache those, like provider cache, whatnot. Or you cannot do that. And you can also manage different provider versions in different stacks, right? So let's wait for this to finish here. All right, here we go. This should be finished any second. Got it. Awesome. Go back to the pull request. And now what you can see here is that, okay, we just added all the stacks in prod, right? So now it provides me with all the plans here. Awesome. So now if I look at the graph, you can basically clear the branch, Terramate list. So this basically now provides me with a list of all stacks. And then of course, if I now run a command in here, I don't know, echo hello world, it does this in parallel, but you can see that the ordering is still preserved. So dev and production can run in parallel, right? But the nested stacks here, so the VPC stacks, they need to wait for the parental stacks to finish first. And that's why we call this approach graph-based, because Terramate provides you with a graph that you can filter using things such as change detection, tags, then tags Terraform or OpenTofu. You can also change directory and say, hey, all stacks in, I don't know, stacks dev only. So for example, if I add this here to the list command, now you can see none are selected because none of those have those tags. But now if I go into the dev and I just add a tag here that says, hey, this is Terraform. So now this will only return the VPC for me because I'm traversing the graph and I'm basically filtering based on certain criteria here. And I'm saying like, okay, all nodes, all stacks that have changed, that are tagged with either Terraform or OpenTofu, right? And that are inside of a directory stacks dev. If I change this to prod, none will be selected, right? If I change this back to dev and I remove the tags, all stacks inside of stacks dev will be selected because the filters are more broad, right? Awesome. So I'm gonna stop sharing my screen here. We're running out of time, but as always, we're running out of time. But I hope that I could give you sort of an idea how the graph-based execution engine here, orchestration engine works in Terramate, and how we can use that to basically create a graph of dependencies, which is a different model So it's a different model and a new model of executing multiple Terraform projects or multiple Terraform state files that can scale and go really, really big. So we have seen projects with hundreds and thousands of stacks, whereas the CI/CD runtimes are still somewhat like 5 minutes, depending on the actual state size of the individual stacks. That's it for today. Thank you so much for dialing in. If there is any questions, I think I've answered basically the 2 questions that I've seen here already. Thanks, Renee, for dialing in. Really appreciate it. And yeah, so then feel free as always to join our Discord at terramate.io/Discord, star repository, follow me on Twitter or LinkedIn or whatnot to stay up to date. So I post about Terramate basically every single day. I'm trying to sort of share as much as information as possible and useful for you guys. So how we think about the development and what we do here. And thanks for dialing in. Have a great evening, or if you're over at the West Coast, then have a great morning. Bye bye.